Yes, hello and welcome everybody. And good morning, good evening, good afternoon, and thank you for joining to yet another episode of Discovering Neo4j AuraDB with Michael and Alexander. So I'm looking forward to this. Hi, Michael, how is it going?
It's good. It's good.
So today we have another hands-on session with AuraDB. So we pick a data set, we look at the model or think about what kind of model we want to work with, create that model, load the data into Neo4j, and then run some queries or visualizations. So that's the scope that's going to happen from now until the end of the hour. So basically, 50 minutes.
Yep.
And AuraDB
and free. It's live.
And it's live, yeah. And Michael is usually errorless, which is amazing. Yeah.
But we always made it work, Alex, right? So I think we never had to give up, but we always.
No, we never. Exactly. That's almost the crazy thing. I mean, we look a little bit at this beforehand, but it's more or less Michael's doing it all in real time.
Yeah, and bring your questions. So if you have questions on a data set or similar data sets or how to do something, let us know, and we're happy to answer any of those as well.
Yeah. So briefly, I think I did this the last couple of times, so I'm doing it one more time, and next time I think we might skip this. But the AuraDB free is a free version of Neo4j AuraDB, which is Neo4j as the graph database, but as a service on the cloud. You get a free option, which you just register for with your email address and set up a password, and you're good to go. You get 200,000 nodes and 400,000 relationships, and you can do as much as you like with those. You can import your own data, obviously. You can use some sample data sets. You can use lots of tools that we make available. So with the new workspace, you get browser, obviously, to query your data. You get Bloom to visualize your data, but you also get data importer to make it even easier to get your data in if you have it available as a CSV file, for example, and want to load it into a graph database.
Yep.
It's free forever, so you can keep it as long as you like it. The only point to note about this is that if you don't use it, it obviously will be paused, but you can always just anytime you go back to it and think, I need to work with it again, then you just launch it again, play, and
you
then
can just resume it. Exactly. Yeah.
All you need to do is go to this landing page. I'll add the link in chat in a second, and from there you are good to go. There's my link. Here it is. And yeah, give it a try, give it a spin, play with it, and have some fun. And today we wanted to look at women's pay gap data. So obviously it's March is always the Women's Equality Month.
But actually, every month of the year should be
every month of the year should.
Month,
yes,
right?
that's true.
Right? So, and it's up to white male privileged people like us to also support that and promote that topic, and it's not up to the women to do this, but everyone, especially us privileged people, should be on the forefront of promoting that.
Yeah. So true, exactly. So that's why I want to mention this again. Here is it's a shame. It shouldn't be like this, and it has to be more equal. Yeah. So we want to also point this out, and we want to, if you can be an ally as a man or as a woman, for women, and if you can just make it public, then this is a great opportunity. And we thought, okay, today we look at this as well from a data modeling standpoint and see what we can do to work with that data, because it's the month. It makes sense. On the Wednesday is International Women's Day. We will do an interesting live panel on all women live panel from Neo4j about women in tech, their experiences, their learnings, their how is it with how's culture in IT for a woman. So
yeah, and I have to say, being a manager at Neo4j, I also do compensation data, at least for our team, and it's definitely not the case at Neo that there's a pay gap. So we definitely pay people by their experience, by their level, and like the location they are in, but not by gender. So I can definitely say, from a Neo4j perspective, at least, that's totally not the case. So gender plays, or other, race or other things play zero role in that as such.
Yeah.
So
yeah, and I think that's important. I think that's what it should be like, and there should be no difference. Your skills and your personality matter, not your gender.
Exactly. Yeah. Cool. So Alex found this. So basically, this is kind of the Wikipedia page on gender pay gap. There's also a European Union page about gender pay gaps. That I can open. Is this one? So, right. So where basically there's a chart over the European Union, and you see that Luxembourg is actually on top with the smallest pay gap. Germany is somewhere down here, almost at the end. So it's not great. No. And I was surprised that actually Estonia and Latvia, who are otherwise kind of really modern democracies with a lot of electronic services in voting, and you would think, and lots of computer science and so on, you would think that it's actually not so bad, but they're currently at the end. Yeah. But as you can see, there's lots to do as such. And interestingly, I didn't see UK in here, but we will look at the UK data today. So
it's EU data. There is no more UK.
Yeah, but it said basically Iceland, Norway, and Switzerland are also in here, right? So I don't know why it's kind of missing, right? So, but anyway, we will look at UK data. So there's from service.gov.uk, there's a really nice data set for gender pay gaps, where they basically have data from the last few years. And the CSV data basically has details on employer information, postcode, company numbers, these SIC codes. I found another source from data.gov.uk, which has these kind of types of industries, which you can probably pull out. And then like the metrics, what's the difference between the hourly, so kind of the base rate and the bonus percentage differences. And then basically the percentages of people, male and female, that are paid a bonus, and quartiles as well, top, middle, and bottom quartile basically as well, and then who put it in some additional data. But that's kind of the rough data set. So let's see how much this fits into a graph model. I also pulled out these SRC codes that were mentioned, which is everything from growing rice all the way down to at the end, dormant country, right? A company. So it's a lot.
Okay. Yeah. Okay.
So we probably can also delete ones that are not used as such, right? And see which ones are actually used.
So that's like
but this is kind of the category, like company category
of the company. Okay. Yeah.
But in this, they had only the numbers, the SRC numbers, and I wanted to see what human readable type of company this is as well. Yeah. Right? And then, because it also had postcodes, I wanted to see if you can extract a little bit of like geography as well. There's a simple postcode data set here, which is basically either just a country or county, region, and with the postcodes, and we can map this one.
I think that's good enough.
I also saw there's a detailed national statistics postcode data set, but that's like 600 megabytes of data or something like that. So it's a lot. And they have probably everything from like education to healthcare to, I mean, it would be probably really interesting to combine this with the pay gap data set. But it's kind of too much for our short time that we have as well.
Yeah.
And similarly on Kaggle, there's also a pay gap data set, which also has like 300 megabytes compressed. So it's basically several gigabytes of data with, as you can see here from a study, from 234 columns. So it's also very detailed. So if you would do this for real, I would probably take one of these data sets that has much more detailed data. But that's kind of too much for our short time frame that we have here. But if you're interested in this, there's definitely data available, and you can dive into this much more as such. Cool, and with that, let's create a new Neo4j Aura instance. I just click on create here, copy this, and I download the gap credentials. And while we're waiting for this to spin up, you can probably rename the instance already and call it paygap. Here, paygap. And I think there was also a question in chat from, let's see, from Holger also. Yeah, Holger.
Yeah, there were two questions, yeah. Do you want to?
So Holger asked a question. Yep. Yeah, so while you're waiting for the database to spin up, because I should have done this before before talking about the data sets, but anyway. So Holger had a question. How can you do quality assurance in a graph database? So Neo4j in itself is a schema-free database. So basically you can add data to it, but also structure to it, like you add basic data. There's no schema as such to restrict what can go where by default, right? So you can basically create any kind of types of nodes and relationships as you want. You can add labels to them. You can add properties to them as you want, or as you have the data available. So for instance, when you have certain data sets from different sources, where some of them have a lot of data and some of them have almost no data available, it doesn't matter because you just store the data that you have available, and you don't need to basically fill empty columns with nulls or something like that, like in a relation database. But if you want to assert a little bit more quality of your data, there are a number of options. So one is Neo4j brings along a number of constraints. Constraint Neo4j docs. So a number of constraints for property existence constraints, uniqueness constraints on both nodes and relationships. And for one of the next versions of Neo4j, we will also see type constraints coming. But these are all optional. So you can add them if you need them, basically. But if you don't need them, then you don't need to add them. So that's where you can constrain more. This label should have these properties, or these properties need to exist on this relationship, or these properties need to be unique, for instance, on this node or relationship as such. Two other ways on how to ensure quality of your data is, or three more ways. One is you can also kind of express your quality constraints as surface statements and then run them on a regular basis, for instance, in CI/CD, to ensure that your database that doesn't get out of sync. There are, for instance, tools like Neo4j migrations, which allow you to do this, which also allow you to basically upgrade things when you update versions, basically, as well. So in Neo4j Labs, there's Neo4j migrations here and Liquibase plugin as well, which allow you to also basically keep data in the database consistent as well as a migration job. The other one is Neo4j GraphQL, where you basically define, let's see, products. Where did GraphQL go?
On the solutions.
Somewhere. Here, sorry, on the right side.
On the right.
I didn't, so the menu got expanded.
Yeah.
So the GraphQL library, which basically allows you to define a type definition as such, and the type definition then controls, this type definition controls basically what data is going in and out of the database. So GraphQL takes care of managing the in-out. And the same is true with object graph mapping, because GraphQL is a kind of object graph mapping. So for instance, if you pick Spring Data Neo4j, for instance, which Alex mentioned for the workshops, then you also define your schema or your model in the classes of your Spring application, and then SDN will take care of mapping your data to the database and will be consistent as well. And there's one or two more ways where you can basically use something like Shackle, for instance. I think Jesus did a blog post on using like model or OWL definitions from Shackle to generate Cypher queries to validate data in your database. And there's also something like triggers in APOC, which are not available in Aura, but are available in self-managed Neo4j instances. They basically can have a trigger which basically, if certain conditions are violated, it will abort a transaction, and then wrong data is not added to the database as such. But all of that will basically be also available more with more constraints coming forward that are optional to add to the database as well.
Yeah.
Super. Cool. What was the other question? I didn't see the other question.
The other question was on from Mohammed. He passed how to proceed in order to pass the AuraDB exam certification test, or the Neo4j, I guess, the Neo4j.
I think it's the Graph Academy certification. Yeah. And the best way to pass this is basically to take the Graph Academy courses, so the beginners courses on fundamentals for Neo4j and Cypher modeling and data import. And after that, I think the Cypher courses, like intermediate Cypher queries aggregations, and I think indexes on constraints. And then this should give you enough knowledge already to pass the Neo4j certified professional certification as such.
Yep.
And so that should be good enough. There's also additional courses. Yeah. There are also additional courses for application development and data science, where you then basically for development, you can do building applications with, for instance, TypeScript or Python or Java as such as courses, or as data scientists. There are also a number of courses for introduction to graph data science, pathfinding, and there are a few more coming as well.
Yeah, and I mean, I think what usually helps is if you have some kind of just work with it a little bit and play around.
Exactly.
And get going.
Build something. Exactly. That's a good point, Alex. So basically similar to what we do here, grab a data set, something that's interesting to you, something that you feel passionate about, turn it into a graph model, start querying it. You can use a Jupyter Notebook to do EDA or just Neo4j browser or Bloom, and then basically work your way through the courses and try things out. The courses also all come with a data set and a live database. So the courses are quite interactive and give you a good round trip interactive experience as well. So that should be fine too.
Yeah.
Okay. Meanwhile, our database should be up and running. Let's see. So we connect to our instance, and I just need to look at my password very quickly. I just restarted my computer, but at some point I will probably need to kill all my 1,300 tabs, which I'm not looking forward to. So let's see. So I just took the password from the end file. Download it. And then it should actually open this database in the import tab. So this was from our last time, so I can clear this. And now we have the data that I just mentioned. So we have in downloads, we have our gender pickup data, 2022 and 23 postcodes and the SIG codes, right? And no, we don't want to do VS Code right now. So the most interesting bit is kind of the gender pickup data, right?
Yeah.
And with these, what I found interesting is that they don't have roles as such, right? So they, which is, because I mean, it's aggregated, of course, but it would be interesting to see, is this kind of a management role? Is this like a more production role?
Yeah.
Is this kind
more
of
granular data?
Yeah, exactly. So that's what I kind of hope for, but unfortunately, this is kind of just across the company, which is very different if you have a company of 10 people or a company of 10,000 people, right? So then it becomes kind of meaningless the bigger the company is, right? So, and I think we can map the company. If we want to, we can probably pull out the role or the employee or something like that, right? So we could say, actually, it's a good question. Should we actually do male versus female as two nodes? haven't thought about this, but it could be
thought about this either.
Interesting. It could be an interesting one, right? So where we basically say this is basically the male one, and this is the female one.
Yeah.
And then we basically use employee twice here as an
yeah, of course.
But we store the male data here and the female data here and the company data here. And then we would basically have something like postcode or city or location here. So that could be like situated in or something like that.
Yeah.
And then we have kind of a category or the SIC code, right, for the company.
Yeah.
What do you call this? Company.
Industry, well,
or type or something like that, right?
Yeah,
so
type.
Kind of for industry. Yeah, this could actually be industry. You're right. Right. So we could have something like this, right? Okay, so mapping this should be pretty straightforward. So we basically start probably with the SIC codes because they're the easiest ones. They have only two fields, the code and description. And we can basically turn the code into our ID property, leave this as a string. I think it's probably better, and we just call this code. Can call this description. Right?
Yep.
So the company has a lot of, so let's do the locations probably next, which is the postcodes. We select properties from file. So we have postcodes. I don't even know what Eastern Northings are.
I would let's just ignore.
We can ignore this, the town, region, country, and country string, which we could also pull out if you wanted to. I'm not sure if you want to, but
because it's United.
It's but just it's Scotland, and Northern Ireland and England, I think.
Yeah.
So the postcode should be our ID here. I hope at least that the postcode is in the same resolution, right? So because there's this kind of AB10 postcode, but then there's also, let's see what we have here as postcode, because these postcodes have EH6.
Yeah,
and
but I guess we
then,
we can potentially delete after space. I mean, that's probably something we have to do afterwards.
Yeah, it's probably post-processing, but let's put this in at least and then take it from there. Okay, the company itself is a little bit more involved, of course, right? So we select properties from files. We want to have the employer ID, address, postcode, company number, which is internal to this paycap. The SIC code or codes, let's store them at least because it sounds as if there could be multiple ones.
Yeah.
And then we can do the differences on the company, and the male and female we store on the employees or something like that, right?
Yeah.
So company link, responsible person, employer size. So we could probably put employer size, pull this out on the industry type or something like that, where it's basically then type plus size gives us some information. So that could be something that we pull out and submit it after that line. It's probably not so important as such.
Yeah.
Right. So this is this information. We use the employer ID here as an ID, and then here we use the same gender paycap file for the male person. So we say basically, male bonus percent, and this, and we just need to rename them basically into bonus percent. This is lower quartile. This is
we can remove this because we know this, or we can derive this information out of the relationship that is then.
And then basically, then also the employees become comparable, right? So then we can basically use the same property name on both and can compare them as such as well. We have our low quartile, lower middle, upper middle, and top quartile, and bonus percentage for these. And I think, because none of these is kind of an ID property, I think we need to use the employer ID again as an ID as well.
Yeah. So we can, otherwise we won't be able to.
So employer ID is our ID here.
Mm-hmm.
And I hope it's an integer for real. I hope so. So, okay, let's see. And for female, we do the same. We select the same file and basically select the other properties that we have skipped so far. And the employer ID as ID. And then we just change these and call them again bonus %, lower quartile, and lower middle quartile. And
yeah, so Ashwa asks if what if this were all in one CSV and not in 3 different ones?
It's actually in one CSV, right? It's actually one CSV file, but it just selects different
yeah,
subsets.
in this case we select, but if imagine the postcodes and the other stuff were also in one, you can like we show here, or like Michael showed, you can just decide what rows or what columns you want to put in what nodes and relationships. So it doesn't matter if you have one big CSV file that contains all of this information, or if you have, like in our case, 3 different CSV file, we map across different things. So yeah. It doesn't make a difference, because we here with the mapping, which Michael is doing now, you decide where what goes or where what ends up in. If it's becoming a property, if it's becoming a node label, if it's becoming a relationship, and a property.
Yeah, exactly. And then for the relationships, oftentimes it maps automatically, because here we use employer ID for both, so we don't actually need to do anything. It does it automatically. But for some of them, like for instance, our industries came out of this CSV file, and the name is different in this CSV file of the column than in the employer file. Yeah. And so I basically had to select employer ID from the company is mapped to SIC codes, basically, from this file. Right? Yeah.
And you see once the line becomes solid. If it's no longer it's solid, exactly. If it's no longer dotted, then it's the mapping is set at least.
And actually, as I said, what we could do is actually we could put the company size, for instance, as a property on the relationship as well, right? And then so we could say we call this size. So each company has basically its size on the relationship, and we can then split it up into from to or min max or something like that, and then use that perhaps also to compare by industry and size. Right. Cool. So this should cover our mapping. So we see
in is not set. Company in location.
Yeah, because you're right. We should map this from postcode. Sorry, from employer ID to postcode. And it won't work because this is only the fractional postcode and this is the full postcode. Yeah. Or what they called. So it will probably not map, but at least in the mapping we should have it here as such, right? You can also download your model with the mapping data into one zip file, which is quite nice. So we can say this is pickup, and then I could send it to Alex, for instance, and he can open it, and he can add the same CSV files and the same mapping, which is quite nice to share this kind of work as well. All right, and then we can do a preview. So to our connected database, we would basically take the first 1,000 or 10,000 rows and map them. And you can see we have our, let's see. I just realized something. It maps the two, see, that's why the preview is actually important. It maps the two male and female to the same node because it's the same ID field. And then it doesn't, it overrides the other data.
So should we set it on the relationship then as properties?
We could set it on the relationship as properties. Yeah, I mean, I kind of would like to have it as a node. Let's see what else we can do. So if you look at this here, I think there's no other.
Or we just
thing that
rename the label,
identifies.
right? I mean, if we give
Yeah, we
it a male
can't.
employee, female employee.
Yeah, I think that's you're right. So let's do this. So we have a male employee here and a female employee here, and we can also set the employee label in addition as well, if you want to later. One thing that I wanted to call out is if you have a large file with a lot of data, a single CSV file with a lot of data, and you have certain aspects that are only true for certain parts of the file, then you can also filter certain rows of the file to go into something or not, right? So you could also say, okay, if parts of my file, so imagine these would be not column-wise, but like there would be some rows or 2 rows per company, one for the male and for the female. Then I could filter this file basically on saying, okay, this is type male, this is type female, or something like that. And then I could basically say this column would be then, let's say, this column would be something, and then it would basically use that as the filter as well. Yep. So that's quite useful for large CSV files that are complex, basically, with the data as such. Okay, our preview now should look different. So we now should have 2 nodes per company. See, that looks much better. So we have each company here, and they are connected through to the male and female and to the industry, basically.
Well. Okay. Yeah.
And some industries have more than one entry, like this one. It's processing and preserving of vegetables also, right? Or this one has business support services, has a number of companies in here. Right? Mm-hmm. So we have, this is mapped, and these locations are not mapped yet. So we need to do this as post-processing as such. All right. Okay.
Yeah, because it doesn't know about it. Yeah. Because it's, as we said here, some of these are in the postcode file. It's only the first part, and then the actual.
Yeah, but you can do this easily afterwards. Exactly. So it took 9 seconds to input our data, and we see now how much data was created, how many nodes and relationships, and we can also look at the cipher that was used for constraints, but also for creating the data as well.
Yeah.
Right? So which is nice. And now when we click on Start Exploring, it opens Explore here, and with Show Me a Graph, I see certain aspects. So for instance, the company name is shown here on the yellow ones. These are like the male and female nodes as such. And I can basically look at some of these. I can also explore them. So for instance, I can go to this company, expand all relationships. So it has a male and a female one, but it seems the SIC codes have not been mapped. And it might be because there are multiple SIC codes. So that's another thing that we need to fix, is basically fix the SIC codes by splitting this field. And then something we've done in the past a bunch of times. Yeah. So let's do this perhaps first, and then we can continue on our journey of exploring this data.
And just because there was another question in chat. So male and female, in this case, are employees of a company. So we got the UK government has data for their companies. I think if you are bigger than or have more than 250 employees, you need to send your payment or your wage information to the government, and they made this public or this data available. To analyze if there is a gap between what the companies pay their male and their female employees overall, not in. Yeah. That's what we said in the beginning, right? We miss a little bit the granularity. We don't get right what kind of job titles do these people have, and where's the difference? So sometimes it could be very much skewed, just not because of. There is actually maybe no pay gap, but the overall company is set up in a way that is, let's say, also wrong potentially, but still, I mean, that's what it is. The company is, let's say, all the managers and all the higher ups are male, and the females are more entry level employees.
Which is also a really important part, right? Which they should also report on, is what's the actual distribution of genders or diversity. Like a diversity ratio or something like that, between like percentage of the different orientations and then versus the total number of employees in a certain job. So it would be nice if there was like a more granular breakdown as well of this, and then also kind of the just diversification in the role. Right?
Yep.
Okay, good point. Yeah. So if you look at the data here, we have our postcodes here with AB36, and then we could actually see. Let's find all the companies that have where see postcode. I think it's postcode this one, and then we starts with AB36. And then return limit 5 or so. So this, we don't have any companies where the postcode is. Oh, let's look at the company as well.
Maybe just do AB or
let's see. Postcode. CB8.
CB8.
So we might not have Scottish companies in there, but if you look at like this one, all the companies that have CB8 as a starting point. Should probably add a space here to be sure, because they're likely spaces. So we have 4 companies in CB8 basically, right? And then we would want to connect this one to the location, where the location postcode equals CB8, right? So and it has Waddington as a city or town. So we want to connect all these companies to this postcode. And so what we do is basically we match postcodes and companies, and then bring this together, right? So we say match a company, and then match a postcode or location, where the company's postcode starts with p.postcode plus space, right? And then if this happens, right?
So you take all the characters in the postcode until the first
from the company, right? So because the company has these postcodes that have like just the first 3.
Yeah.
Sorry, it has the full postcode, and our postcodes are just the first 3 letters, and we are just at a space. So in case there's something that's called whatever CB81 or something like that, then it would not basically match here. But because you have the space, we add the space there, and then we say this companies in this location basically. So we just create a relationship according to our model. Yeah. And then if we return count star, it kind of tells us how often this worked. And let's see. So it created 2,253 relationships. So there should be now this in relationship, which connects cities to companies, right? And then if you have some of them that have more than a few, so for instance, here's one that has 4 or 5 companies and so on. So we could actually also see for which locations do we have the most companies, right? We can say return comma count, and then order by degree sending limit 10, 20. So we see our first 20 locations, and we got the tabular information. So there's Camberwell has most reported, which is kind of surprising, right? So I would kind of expect London to have most reported.
Yeah.
But it's probably by region, right? So if you aggregate it on greater region or on region, then it's probably so it sums up. Yeah, so then we see that like Greater London has 283 companies, City of London, which kind of go together, Westminster, Surrey, Kent, and so on. right? So, I mean, in the file, there are like 2,300 entries of companies that have reported their gender pickup data, but that's basically by region. That's kind of makes more sense, right? So this basically counts how many relationships are there on the location file, and then we just sum it up by region, right? So that's kind of how this works, and then we order it by degree descending as such. Right. So that was our first fix that we wanted to do, and the other one, if you remember, was this industry that was not fully populated because some of the companies didn't have or had like multiple SIG codes in there, right? So we can basically find all the companies that have where C dot contains a comma or comma, and then we just say how many companies are there.
Oh, yeah. Okay. That's good.
Have this, right? So 827, so almost half of them have multiple SIC codes, right? And so what we would do here is we find these companies, and then we take this company and split the SIC code by comma. And we take this, let's see, codes. I've just that we see what it looks like is basically we return a company and the codes, and you see now we have these codes. Yeah. So this one has, for instance, 3 codes. And then we take each of these codes and connect them to the actual industry, right? So we take codes as code, we turn this list into rows, and then for each row we find our industry where I.code equals say trim code, because there could be spaces or something weird between them. Okay. So I'll just trim this left and right. And then if you found an industry, we basically connect the company to type industry. And we don't need to worry about existing relationships because we imported these industries from this other CSV file. There are no industries with comma separated IDs or something like that, right? So sometimes in past imports, we had all came from one CSV file, and then we kind of created some industries that had multiple codes, but in this case, we don't need to worry about it. So we don't need to delete outdated type relationships. We can just create the new ones and then can return count star. So, and if it's 800 comma in there, so it's at least 1,600 new relationships because it's at least 2 of them, but it's between, I think, 1,600 and 1,800 or something like that. And so we have now 1,600 new type relationships. And we forgot something. What we forgot is we didn't set the size on this in relationship, right? So remember in the import, we actually set the size on...
Oh, the company size, employee size.
Exactly, we set this on the relationships, right? But we can still do this. We can just run this again because merge is idempotent, so it would not create new relationships. And we just say, for instance, on match or just set p or rel. You can call this rel dot size equals c dot employer size, basically, right?
So what we did is we overrode the current relationships. And now we need to set it back.
Yeah, so now what we did is basically we created the relationships without the size information for these split ones. And,
of course.
I forgot this. And now we are just doing this again. And merge if the relationship already exists doesn't do anything. So we could also do match here, right? It doesn't matter. I just wanted to show we can run merge again. It won't create new relationships because merge is idempotent, right? So it can be run multiple times and it won't.
So just to because I was confused a little bit here. So in the beginning, what we did was we imported all the data, but some of these had more than one SIG code. So that means it didn't create that relationship because it couldn't find the connection, obviously, because if you have three or more,
the SIG codes have exactly one entry,
exactly. Yeah. So then that's why it didn't create a relationship. Now we recreate now we're creating that relationship because we spin it out and we unwind that list into individual items, and now we create the relationships between the company and the SIG codes, and we have to add the employer size again.
Because we forgot to do this, but now it's there. So now all in relationships should have not in type relationships, right? All type relationships should now have size information. So we could even use size here as an attribute in our visualization. And if you zoom in, then you see actually the size information here on the relationships as well. Right? And what we can do now is we can turn this into real numbers as such. So what we could do is we find our types and take our size information and, for instance, say with rel, split, we just rel.size, we split it by 2, basically, right? So where rel.size contains 2, we split it by 2 as sizes or something like that, right? And then we can just set rel.min size is equal to integer of sizes of 0. So the first element, right? So because if we split this 1,000 to 4,999 by 2, the 2 with the spaces becomes the in between, and so the zeros element is the 1,000, and the upper limit is basically the 1. Right? So this should give us hopefully 5,400 properties, and now our type information has basically not just the size, but also the min size and the max size as integers, as you can see here. Right? So we can now also group or aggregate things as well. So we could, for instance, say which industry has which company sizes or average.
We could visualize it in Bloom.
We could also visualize it in Bloom with the width of the relationship, right? So we could also say now, I think we need to refresh the perspective. So, and then we can click on relationship and say the type relationship has now an GUL-based styling of, let's say, min or max size. What do we want to take? Let's say max size, which is a range, and we want to apply size. And the min point is, what did you say, 250?
250, I think, is,
let's say 10,000. Right? And then the max point is 4x, and the smallest size is 0.25x width. And then if you apply this and look at these in relationships, at these type relationships, we should actually see, let's see, data.
Now we get everything.
But you see that they have different widths, right? So for instance, this company, this industry is public or safety activities. And these companies are like Cleveland Police, for instance, is
big ones.
Has you can click on those. We see that it's 5,000 as max size, right? I'm not sure if there are actually ones that are bigger than this. This has also 5,000, or perhaps there's like something like more than X or something like that, right? So if we say we find out types, and do is we do rel.size, count star. Let's look at different sizes. So it says, see. So probably it failed to pass these here, I think.
And more, it doesn't know what to do.
20,000 and more, and then it has probably also less than. Can you see that here? So we
less than 250.
Also handle these as well, right? So and then and then we should probably find these and set them as well. But it's probably too much detail now. Yeah. But now what we can do is basically we have our male and female people as well. So we should also be able to compare this, right? So basically what we can do here in our query. So in Explorer, we could basically, if I clear this out really quick, we can do this pattern. So we have a male employee to a company. Sorry, we have a female employee, a company, and then the male employee, right?
Yeah.
And now you could basically say, this is our data, right? And now we could say, if we, for instance, look at the top quartile here, it's basically 61% male and 38% female. And then you can take the different numbers as such and turn them into, for instance, either visualizations where we say, we do the size of the nodes based on the quartiles, for instance, or something like that. So, for instance, you could say, what's the that's low middle quartile or something like that, and then compare them by size. That's something that we could do visually. So then the sizes of these nodes would kind of change based on the values. Right? So that's something that we could do. So, for instance, if we say here, rule-based, if we say lower middle quartile is a range, and we want to change the size, for instance, by this, or we can also do colors, right? So we can, for instance, say the min point is basically, I don't know, green, white or something like that. Right? So something really light, and the highest one is green. Then we can apply this color, and then we see this how it distributes. Especially if you zoom out, right, you see a few dark greens, and the other ones are really light. Yeah. Some of them are even, and we can do this the same for male basically, and then you see how it compares basically as such. So that's one. So that was top. No, what did we use? Lower mid.
Right?
Lower mid. Yeah. Range, color, and then we just pick, let's say, something bluish or so here. This for nothing, and dark blue for that. And then we say apply color, and then you see that the male ones are much darker than the female ones, for instance, right?
Yeah.
So that's something that you already see here in the visualization. And of course, in the query, we can do this as direct comparison. So we can say, for a company, we have our female employee and our male employee. And then we can basically compare the lower middle quartile of the female one to the male lower middle quartile. And then what we could also do, let's say limit 10 or so. Right? So we see kind of that's the distribution of the two. And then we could actually connect this to an industry, right? So we could also say this company has a type of a certain industry. I think it points to the industry. And then we could say basically aggregate this, for instance, and return the industry name, description, and for instance, the average as female, as male, and then description, and then you can do this all in one, and we just here use the average. And see across an industry, we can basically see these 20, and we could probably see how often this industry comes up. Frequency, order by frequency descending. 10, 20, right? So we count how often this industry comes up in this in this combination, and the top industries are then basically So in secondary education, females have a much higher quartile than males because of the distribution, right? So if you look at the data here again, it also says, this is actually the count. Interesting. So I think we mixed this up a little bit. So that's kind of the number of people in that. So that's actually the numbers, the quartiles, and the differences are basically the medians between the pay, basically, right?
Ah, okay.
So what we should actually look at. This is actually the distribution of people. Which also makes sense, right? So if you look at this, then you would say, in education, the female percentages are much higher, for instance, right?
83% are in primary education or something like this.
But for instance, let's say in social work, right? But for instance, in motor vehicle repair, it's kind of the other way around, right? But what's interesting now, this is kind of the distribution. But what we're interested in is actually also the average company diff mean hourly percent is basically that's the actual pay gap, right? The hourly pay.
Okay.
And so, oops. So now we see actually, and we would want to actually order this by not by the frequency of how many are there, but we want to order this by pay hourly descending, right? So you see kind of that the pay gap in construction is pretty high between males and females, right? Which again goes back to where do they work, right?
There's only one company, so I mean maybe it's a little skewed this one here.
Yeah, but, then let's order by.
No, I think the order is great, but maybe let's say I don't know. There's at least 5 or so or 10 companies with the same.
Yeah, good point. Let's do this as description, and then where frequency is greater than 5 or so.
Yeah.
So in description, female, male, and pay hourly, and then so this is basically the frequency. So this is kind of the frequencies, and so we see in banks, it's actually pretty.
It's close enough, yeah.
Kind of close in terms of like distribution, but the pay gap is 30%, which is pretty high, right? So,
yes,
so banks
I
are
see.
Doing that job of paying their employees.
Yeah.
Right?
Banks have.
For instance, that's also financial institutions. Construction is also pretty high pay gap, but there's also a big gap in terms of like how many male and female employees they have, right? You could also look at who has the lowest pay gap. If you look at ascending pay gaps, okay, there are some negative ones, which is interesting. So that means there the women earn more than the males.
Yeah, in fitness facilities, for example.
Yeah, but private security is interesting, right? So there's few women employed, and then that's kind of they earn more. Okay.
I guess this is a clear. This is gender stereotyping now, but I would assume in private security activities, the male ones are the ones who are actually bodyguards, and the female ones are the managerial type, and this is why I would assume
I could have something like that.
Hostesses, maybe something like this.
Yeah. But so it seems that in fitness, that's interesting that fitness trainers basically are paid the same, which is good. In manufacturing, that's actually interesting, right? So there's in manufacturing, there's a discrepancy in terms of employment, but the pay gap is actually much lower.
Yeah,
that's actually good. That's temp employment. That's also, I guess, unlicensed cafes, renting, museums, so public institutions seem to be also okay in terms of nursing and care. That's probably also a really low male percentage as well.
Yeah.
So that's interesting, right? So you see this kind of pattern. So we have a company with male and female, and the industry. That's kind of our graph pattern that you're looking at. And then we didn't take the location into account. We could also pull in the location here and see if there's a different distribution in the different. If you don't look at industry here, but if you would look at, let's say, the location. And if we say we just look at the country string or something like that, then we could see, sorry, not I. Then we see basically that the pay gap in England is actually higher than in Scotland and in Wales.
Oh, yeah, okay. Yeah.
And it also seems that there's no data for Northern Ireland as well, right? So which is interesting. Or our postcodes did not cover. That could also be that these postcodes didn't cover Northern Ireland. It could also be the case.
Yeah, could be.
So, but that's also something where you can see basically Candace.
Yeah. Now what
is this something location based, right? And we could kind of drill down into the actual towns or something like that, right? So we could also say this is kind of now like town or something like that, right? And then we would say, okay, where's the pay gap lowest in terms of towns? But then you would also need to look at what kind of businesses are in which towns more prevalent. For instance, in London, there's lots of financial industry, and we saw that like finance industry had 30% pay gaps and things like that, right? So that's definitely something to look at.
That's true. I mean,
but I'm just seeing that we're over time.
We're already over time. The thing that just came to mind for me is now we could take this and open a Neo4j and just plot it because we have the geospatial information. We have latitude and longitude. We could set it or put it on a map where we say, okay, where is the little color heat map.
Yeah, like the blobs basically, right? So in terms of like so distribution. And Neo4j would be really good for this data set, right? So that could be a good one for visualization, where you also have different charts of different distributions, but then also by industry, by geo, and so on. That's a good point. So if you don't know what Neo4j is, it's a labs project as well, and it's a basically low-code dashboarding tool that connects to your Neo4j database and then can put charts, graphs, and maps on a dashboard really easily by basically taking similar queries to those that we just ran, and it visualizes then the data as such. And definitely something to try out with this data set as well.
Yeah.
Cool. This was a good one.
Definitely.
As well.
Yeah. It was really good and very interesting, and lots more things to do. You can, as you see, we have just basically started with this data set. You could now go on and explore more, do more, run more queries, play with visualization, play with Neo4j, do other stuff. So there are lots of opportunities and possibilities. But I guess for today we wrap it up. So thank you for presenting and for live demoing, Michael. Thank you all for